Okay, well, welcome back to part 2 of this tool that I'm making for the Kurt vise, and I imagine it can be used in any vise. So, just to recap, I got the idea off a YouTube channel, and I did my own drawing based on what I could interpret from that YouTube channel, and I did my own little machine list of what I needed to do in steps. And when I last left you in part 1, I had showed that this unit had a little over 1 thou, maybe even 2 thou, I can't remember now, of difference across the whole surface was one item, and the other item is, per my drawing, I had forgot to go ahead and put these bevels on the part itself. And then the third item was that this back piece here being radiused, so that as this tool is adjusting this way on a part, pushing it into the vise, that if the part was off at all in the X direction, why this was pushing in the Y, it would compensate. I think I got my X, Y, Z's correct there. So, as you know, I said I still was figuring out what to do here. So, interesting enough, the other day I scribed a center line. Ah, there goes my light again. Jesus Christ. One of these days I'll remember to turn the timer on. So, guys, there's a lot of guys that go crazy when my light goes off. My machine shop has a motion sensor timer on it, and when I first got the shop going, I used to walk in and out of the shop constantly, so it really worked out well that I didn't have to turn the lights on, didn't have to worry about shutting the lights off. Now I spend a little more time in here, and I do tend to not change the light to the on mode, so let me do that. Okay, the light won't shut off anymore as we're talking here. And so let me get back to where I was. So I was just getting, I had scribed a line here. I think you can see it on the back of the part, center. And I was going to put it in the surface grinder and was going to shim it and create basically a small wedge. And interesting enough, it was sitting in the surface grinder, ready to go. And my phone rang, and who is it but my good friend and mentor, Chewy. He's a retired tool maker after 40 years. Just a great source of knowledge, and I'm very fortunate that he's my buddy, and he does come over and work in my shop with me. And I mentioned what I was going to do, and he just read me the riot act. Don't you dare do that. Don't you touch it. It's perfect. There's no reason to put any kind of chamfer on the back of that, or radius on the back of that. He says, anything like that, he goes, one, the vise is going to do. The vise is actually going to take up some of that. And we had a little discussion on that, and I'm going to go over to the vise and show you findings from our discussion. So let me cut now, and we'll go over to the vise. Just a quick discussion real quick. If you guys don't have a set of spacer blocks like this, they're inexpensive, they're pretty much right on, and they are so useful when you need to build something to act as a support, where you don't want to use gauge blocks. In the construction area, gauge blocks are for measuring. These are for use in the vise and stuff. So anyway, look them up. Spacer blocks are real inexpensive. They go together with set screws. Okay, we're over at the Kurt vise, and these are 1-inch spacers. There's 2 of them here, and I've gone ahead and mic'd them. I mic'd them with a Starrett mic, and that's not the number, but that's Starrett mic that reads to the whatever, way beyond a tenth. and these guys are within a couple tenths of each other, of 1 inch. So interesting enough, if you put this guy right in the center of the vise and you tighten down, okay, I got nice grip on it, it's tightened down, and you bring the other guy over here, it basically won't go. It's tight, but it won't go. And bring it over here, and basically it's very tight, just about at it. Okay, and fooling around a couple times, sometimes you can get it to drop in there, but no. Okay, now if we take this same 1 inch gauge, move it off center just a little bit, and tighten the vise, come over here, it'll go. Come over here, and it won't go. Won't go. So what's happened there? The vise, the back jaw of the vise has canted with the part. Same thing if I move the part over here. It won't go. Over here. Well, not going to go there. Not going to go there, and it'll go there. Yeah, because that's the side, and actually it's fairly loose. So, is it a thou? Maybe it's a thou at most. But what Chewy explained to me was the back jaw of this vise is going to move. It's the front jaw that's stationary. But the back jaw is going to compensate. So there's no need to radius the back of that part. I'm the junior, right? I agree with him. I have to agree with him, right? I think he's somewhat correct. He's probably pretty correct. Well, and then of course, we also know that you can always put in, when a part is off in the back, you can use a round rod in the back jaw to push. And that's basically what the radius idea in this part was supposed to do, was to compensate in that fashion while the tool is compensating in the other direction. So we're going to do some tests on that, and before we move on, I'm going to show a couple little test things here. And then also, subsequent to all this, after the whole discussion with Chewy, my other good friend, Carl, who we've done videos over his shop with the, what have we done? We did the measures, whatever the heck the damn thing's called. I'll write it on the screen. We've done that. We did the Gortons over at his shop. We've done a few things. Very, very intelligent fella, and I kiddingly call him Mr. Wizard. Well, I went over there, and we were chatting about it and looking at the build, and he came up with I thought was a heck of an idea. And we'll get to that in a little bit. But to create the chamfer. The other thing that came up in comments from a lot of the viewers that looked at it was to put a set screw in this unit, or even Keld over in where are you at, Keld, Sweden, somewhere up there in the northern European countries. He even did a nice couple of sketches where he showed a set screw that would hold as a shouldered screw on both sides. Well, I got some thoughts on that too, and so we'll get to that. And then whether the bevels here are bevels or chamfers are really necessary. We'll get into that as we do the tests. Okay, so let me do some setup, and we'll get back to that. Okay, so let's start with a little test. So here's a block of aluminum. You can see it's rough sawn on the back side, rough sawn on the bottom. It's got a pretty good face right there. So we'll put that face against the fixed jaw, and we've got a parallel there. And let's start off with just go ahead and setting it in there, put it in center, and go ahead and let the fixed jaw, the rear floating jaw, do its work. A little bit of tightening on the vise, a couple taps, parallels firm, and what do we have? Well, I think you can see. Can you see that there? The feeler gauge will go in there behind the part. On this side, it won't go in behind the part. So, if reference of how this thing's twisted, we're not flat against that face. All right, so let's pull that back. Now let's try the old rod. Put that in there. Give it a tighten. About the same amount of degree. Couple taps. Parallels. Parallel's not tight. We'll give it another one. Parallel's not tight. All right, let's try it again. See what's going on there. Set that back in there. Piece of aluminum rod right there. Give it a little tightness. Couple taps. That sounds like it's down on the parallel. Okay, same thing. What do we have this time with the feeler gauge? Feeler gauge won't go. Feeler gauge won't go. So what we're showing there is that the rear jaw, even though it does have some movement, is not compensating with the back of this part being rough sawn to put it tight against the front jaw. So now let's try the tool. So we'll pull that out. Back this guy up. Put my tool I built in here. Put the part back in. Crank it up a little bit. So even adjust it so that the wheel there's got to turn. Okay. And give it a nice little tight, same thing. Couple tap taps. Sounds like it's set well. Nope. Okay, there it's tight. And what do we got? Interesting. Feeler gauge goes in, feeler gauge doesn't. So it mimicked the back of the jaw. So this does need to have some sort of bevel radius in it to compensate. That's what it certainly appears to be needing. So let's try something else here. So let's back this up. Put a dowel right here. Whoop. Put a dowel right there. So it stands up. Okay. Same tighten. Couple taps. Sounds good. Parallels tight. And what do we got? Feeler gauge won't go. Feeler gauge won't go. And you can actually see I don't know if you can see it or not, but let's see if we can get a quick, 223, .262. So you can see there the part needs to roll to bring that straight. So to use this tool in a fashion where it's going to work in two directions, it does need the radius along the back. So let's work on that. But let me bring you right back in a second. Okay, I'm going to explain why Chewy said don't radius the back of that tool. And so here's a larger piece of aluminum. You can see it's basically got good 90-degree corners, and then it's got a rough sawn face here. You can see what I'd sawed it off for something. Okay, and let's put it in the vise. And of course, if we just tighten down on the vise is hitting here, and you can see there's no space here. Okay, so the back jaw is not going to take up for that. Let's see if we give it a little tightness. Talk it down. Parallel's tight. We're good on the face. We're not good on the face over here. Okay, I'm not tight over there. So the vise is basically pushed against here, and the vise is canted just a little bit so I can actually get the feeler gauge in the back side there. And we're talking about, is this feeler gauge marked? It is, I can't read, 8 thousandths. Okay, so here's why Chewy was barking at me saying don't radius the part. I don't know that well, let's try it. Just for shits and giggles, let's try it. Okay, let's try the tool in here. Let's try the tool in here. How am I going to do this? I think I can do it like this. Put that parallel there, put that there, and where'd my dowel go? There's my dowel. So we know if we don't radius it, it won't work. Let's try it with the dowel behind it to create the radius. Okay, it's up against the part. Another tap tap. Parallel's nice and tight. Nice and tight. Nice and tight. So there, the part has rolled it up against the jaw, and the dowel has created the radius to push the part tight. So it works pretty good. But here, okay, I've been trying to get at something. Here's why Chewy's telling me I don't need to do that. And the reason is because some time ago I purchased a couple of things from him, and this is the item that I purchased from him. This large ball bearing, which he ground a flat on the back of it. So that guy sits in there against the jaw. Tighten it down. This parallel's too high. Tighten that puppy down. Give it a couple of taps. Parallel's tight, and it's not going to go. The feeler gauge won't fit. So he's going, there's really no reason. You have another tool that will do what you want to do for the radius. So just leave your tool for when the part's straight and you have a difference in the other direction. So that's where I was getting my mentor on my hiney. He made this one, and I had purchased that one, and I'd also purchased this from him, a smaller version. This guy is 562, roughly, somewhere around there. So, but we're going to progress on, and with that said, since I can, and I have the tool to do it, I'm going to make another Chewy ball for myself. And this one is it's in a 15/16 collet, so smaller than the large ball. Where'd my calipers go? The large ball that I showed you was 1.5 inches. So I'll have something at about 1 inch and then something just over a 1/2 inch. So we'll be over the surface grinder later, and we're going to make ourselves a Chewy ball. All right, we'll be back with more discussion now on this tool. Now what I didn't address, and I didn't want to move the camera, but so far in my testing, the two bevels don't come into play, well, especially if I'm using that dowel back there. It's really a moot point. by leaving those chamfers or those bevels off, I end up with more strength for the unit itself. But I got an idea. I don't have an idea. Carl had an idea. My good buddy Carl. So we'll be back. Okay, here we are making a chewy ball. Bring you back and we get down to an area of flatness that we want there. Okay, well, there's the finished product. Let's see if I can get it out of the collet right there in front of us. No, it's going to drop down in. Well, let me grab a magnet. Okay, let's see if we can get it out of that collet. Tight fit. There we go. Hey, that looks familiar, huh? That's from my buddy Brad, Tactical Keychains. So there it is. Got a nice ground ball. And you know something? I think this is going to be called a screw ball. Screwy balls. Screwy ball. And I think I'm going to put these on eBay for sale. Screwy balls for sale. Alright, let's get back to the project. More on my sale literature later. Well, hope that's in focus. And anyway, here's the modification that Carl and I talked about, was to go ahead and actually insert the dowel in the back of the tool. So you can see I had a waste piece there in the vise that allowed me to drill the hole. Now, unfortunately, you didn't see any work on this. The card was full and I didn't catch it, so we have none of the work that I did there. But anyway, you can see the waste piece there, and I opted not to go all the way through the part, and I did that for a couple of reasons. One of the reasons was that way you don't have to chase it falling through. I don't have to pin it to stay in place. There was discussion from some of the viewers, quite a few, that thought about pinning this piece, and I was really leaning forward to doing that. And at least for me, I'm not going to do it. I'm going to leave it loose. And I think it's a little more user-friendly because I can actually pull it out very quickly and use this as a parallel, or leave the radius in there. I was thinking of burying it, something down behind there. So anyway, I was looking at using another method where I had a knob on here, but that really just could end up hitting on the vise. So I'm happy with this setup, and let's go try it as a test in the vise. Okay, this is the original block we had earlier. There's about 70 thousandths of difference in the length of this block, in the thickness, and about 10 thousandths on the face about a square. The back is square. So we'll crank it in there and grab our little tapper. Parallel's nice and tight, and the part's in there really nice and clean. Works well, and you can see here the variance. I hope you can see that, but the variance that's on the back of the block there. And let's see with the feeler gauge real quick. There's 75 thousandths right there. So 75 on that side, and can't fit 75 thousandths there. So it adjusts real nice. and I'm happy with the pin, the way I set it up. I know everybody's going to have a different opinion on it, on how to do it. And then just for the fun of it, this is the other block that you can see the taper there on the face, and you can see the roughness and the offset of that face there also. But again, whoop. Parallels nice and tight, parts nice and tight. So, real happy with the build. I think it's going to be useful, and it'll get limited use in the shop, of course, but I think it's going to be really great. I think on bigger parts, rougher parts, the chewy ball may work good. The thing about using the ball is you can see even on steel, it'll dimple because of the pressure of the point there. But if this is one of your final passes and you allow for it, it wouldn't be a problem. So hope you guys enjoyed the build and a little bit of testing, and we'll catch you soon.